A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of calcium hydroxide. What was the concentration of hydrochloric acid in the original solution? So first, let's break apart the information given to us in the question. You can see that there's 75 milliliters of hydrochloric acid with an unknown concentration, and that's what we know for the hydrochloric acid. We know that there are 27.3 milliliters of 0.175 molarity of calcium hydroxide, and that's the information we know for that. And we know the two are titrated together, which means that a reaction is happening. And our objective is to find the concentration of hydrochloric acid in the original solution. Now, our first instinct after we see this information, like, what do we do with it? Well, the 75 milliliters here, that's going to be our volume of the hydrochloric acid. And an important thing to remember is we need to convert this to liters to do anything with it. And we have the unknown concentration here, which is molarity, and that is unknown. This is going to be our volume of calcium hydroxide, and we also need to convert that to liters. And this is the molarity of calcium hydroxide. And then our objective is to find this, the molarity of hydrochloric acid. So we're just going to take this and rearrange it into a way that's really easy to see very quickly. So we got hydrochloric acid, and we have an unknown concentration of that. And we have 75 milliliters. An important thing to remember here, and this is going to be a common mistake, which is why it's going to start in red, is a lot of people will leave this in milliliters, but we have to convert it to liters first. So I'm just going to do that real quick. 5 liters. So we went from milliliters to liters there. And now we're going to look at the calcium hydroxide. And we have 0.157 molars of that and 27.3 milliliters of it. And once again, we're going to hit the common mistake of leaving that in milliliters. We got to convert to liters. Alright. Now if we're going to look visually at what is happening in this problem, we've got to know what is happening. So we're going to draw a little beaker, just to picture in our head what is going on. And we're going to have our beaker of hydrochloric acid. And we don't know the concentrations of it, so I'm not going to fill that up yet. But there's our beaker filled with HCl. And then we're going to have another beaker over here being filled with calcium hydroxide. And now this beaker is going to be poured into this beaker. And that is visually what is going on in this problem. Now something we know we can do straight off the bat, because we have two different chemicals, they're being titrated together, so a reaction is happening. So what we can do is go and write the balanced reaction. So we're going to have hydrochloric acid plus calcium hydroxide yields H2O and calcium chloride. Now another common mistake here would be to just write the equation out and forget to balance it. So if we balance the equation out, we're going to get 2 hydrochloric acids and 2 water molecules. And since we now know the balanced equation, we can actually go back and fill in the concentrations that are inside of these little beakers and make a more accurate model of what's actually happening. Once again, we're just putting like 2 HCl, 2 HCl. And that's what we're doing there. So now to go back to our original objective here is just to find the molarity of hydrochloric acid. How we do that is we're going to use the equation we know of moles equals molarity times volume, or concentration times volume. Now we don't know the moles of hydrochloric acid we have, but we do know, or can find out, the moles of calcium hydroxide we have. Because this can be molarity times volume, and we have the molarity and volume for calcium hydroxide. So we can go down here and just plug those two numbers into our equation. And remember to use the liters that are, or the volume that's in liters, not milliliters. So if you multiply that out, the calculator is going to tell us this really long number here. And that is the moles of calcium hydroxide. Alright, so now we have this giant long number here, and now what do we do with that? We can convert that, the moles of calcium hydroxide, to the moles of the hydrochloric acid, which is something we learned a long time ago. It's a handy dandy little tool. So, another little mistake is you would just like leave the number as is and you wouldn't label it. And that means like you could start mixing up what part of the reaction you're working with, like what unit you're in, and then you might mix something up. So we have the moles of that, and we multiply 1. When we look at that, we are going to get a really teeny tiny number. And at a part like this is where it is really important to make sure that you labeled everything all the way through, because you did this big reaction here, and you might think that you're done, but you're still in moles. You aren't at molarity yet. And molarity is our main objective. So how do we get the moles to molarity? We go back to our original equation here. However, we're trying to find this one, so we're going to have to make the concentration by itself. So how do we get it by itself? We're going to divide by volume, and we end up with moles divided by volume equals concentration. And that's the equation we're going to use. So we're going to have the moles of HCl and the liters of HCl, which once again remember to use liters, not milliliters. And that will give us the concentration of hydrochloric acid in the original solution. And a tiny correction here. Milliliters to liters is 1/1000. I multiplied it right, I just didn't actually write that down correctly, so I'm going to fix that real fast on both of those, and then those were now correct. So cool.